Happy Monday morning, everybody, from Mr. Colodi. And that's right. I hope you all had a good weekend. And we are going to get rocking and rolling this week with applications of exponential functions. Okay, so on Wednesday, I gave you a lesson where, yes, we learned about exponential growth and exponential decay. And those were very general equations, growth and decay, 1 plus r and 1 minus r. This week, we're going to get into it with populations and money. All right, so let's talk about populations first. Here we go. So when specifically speaking about population growth or decay, this is the formula we're going to use. So let's talk about these variables. P stands for, you know what, I'll call it the ending population. In other words, what's the population at the end of whatever we're discussing. P sub 0, and that sub 0 basically means at time 0, so that represents the initial population. E, okay. E is a number, and wait, what did I just say? E is a number? No, E is a letter, but E is actually representative of a number, just like pi is representative of a number. Pi is roughly what? 3.14, correct? And what does pi represent? Pi represents the ratio of the circumference of the circle to the diameter of a circle. But that's not what we're talking about right now. We're talking about E. E is a number that represents natural exponential growth, and E is roughly equal to about 2.718. Now that said, we're never going to use 2.718. Never going to use 2.718. We're just going to use E. And there is an E button on your calculator, and I'm going to show you where to find that. I hope some of you downloaded the smart software on your computer or your laptop if you don't have a graphing calculator. We're going to use it this class. K represents the rate of growth or decay. And keep in mind, it has to be written as a decimal. All rates have to be written as a decimal. And finally, T represents time. Okay. On to the examples. Once you understand these, to be honest with you, if we were actually in class, I would do 2 lessons in one day. I would do the compound money and I would do population all in the same day. But since we're at home, I'm breaking it up into 2 separate days. You're welcome. In 1970, the population of the US was 205,052,000. The birth rate was 18.4 per 1,000 population, and the death rate was 9.5 per 1,000 population. Estimate the number of people in the US in 1991. Now that sounds pretty complex. So one thing to note is that in this country, in this world, think about it, people are born, and let me get on video for just a second so you can see me flames. In this world, people are born every day. People pass away every day. So that balance, that net, in other words, let's say that 10 people are born and only 8 people pass away on a given day. The net gain is 2 people. So the world has increased in population by 2 people that day. So with that said, to find the rate of growth or the rate of decay, you need to sometimes calculate the birth rate. BR is the birth rate minus DR, the death rate. If they don't outright give you K, you might have to take the birth rate minus the death rate. So let's get to this here. P sub 0. Start listing things out right here. Is the 205,052,000. The K, again, birth rate minus death rate. So it says 18.4 per 1,000 people. So 18.4 over 1,000 people. And the death rate was 9.5 over 1,000 people. And so if I go to my handy dandy notebook, no, my handy dandy calculator, I am going to take the 18.4, see if I can do it with my pen, 0.4 divided by 1,000 minus, what was it, 9.5 divided by 1,000. If I hit enter, I get 0.0089. Great, let's go back to our problem and work it on through. So then this is 0.0089. There's my K. T, notice I'm not even writing E. Why? Because E is just E. I'll explain that. We got to think about this. From 1970 to 1991, how many years have elapsed? 1991 minus 91 minus 70 basically is 21 years. From here, it is honestly just a matter of straight up plugging into this equation. So I'm going to do P equals the 205,052,000 and 52,000. My own handwriting, I thought that was an 8. And then I write E raised to the power of 0.0089 times 21. What I need to do is plug this equation into my calculator. Let's go back to our calculator right here. And let's get to it. So I'm going to do 205, oops, there. 205,052, 000. Notice I didn't use any commas. And then I'm going to hit E. I want you to look, if you hit the second button, and look at the LN button. Let me put the cursor over it. See this LN button right here? And do you see the E to the X power that is right there? So I'm going to hit the LN button. And look on the screen. It says E raised to a power. How cool is that? You do not write 2.718. You write E to the power of. And then I do 0.0089 times 21. And I hit enter. And I get a big number. 247,191,565.7 people. There's an issue with this. Can you have 0.7 of a person, Griffin? No, you can't have 0.7 of a person. So what we're going to do with people is round to the nearest person. So I'm going to write 247,191,560.7 is bigger than 0.5, so 566 people. Round to the nearest person. Whoop, there it is. We got it. All right, so let's do example 2. In 1995, the population of a certain city was 34,000. I'm not even going to hesitate. P sub 0 equals 34,000. Since the population has been growing at a rate of 1% per year, K equals 1%. I don't have to do birth rate minus death rate here. It just tells me what the rate is. But wait, I have to write it as a decimal. So how do you write 1% as a decimal? I think of 1 cent. How do you write 1 penny? It's 0.01. Or just take the decimal and move it 1, 2 places to the left and fill it in. 0.01. All right, we're rocking and a rolling. Write the equation for the population after T years. So they're just saying, they don't even want an answer here. They just want a general equation. So it's just going to be P equals the P sub 0, which is 34,000. E, make sure you always write E, raised to the power of 0.01 times T, because they don't tell you what T is. Guess what? You're done with number 2. That's all that number 2 is asking for. Number 3, maybe we'll do 4 examples because it's a little overkill to do all the stuff right here. In 1987, the population of the Soviet Union was 282 million people. All right, so P sub 0 is 282 million people. All right, it had a birth rate of 20.1 per 1,000 and a death rate of 9.8 per 1,000. So I have to do birth rate minus death rate here. So I'm going to do 20.1 over 1,000 minus 9.8 over 1,000. I'm not going to go to my calculator again because you saw me do it on the first example. but if you do it on your calculator, you should get 0.0103. Then T, estimate the population in 2003. Okay. Okay. How many years between 2003 and 1987? That's 16 years. Okay, got all the pieces we need. So the ending population is going to be the 282 million people. E to the power of 0.0103 times 16. I will go to my calculator one more time just to reiterate how this is done. Okay, in case you need a little extra help, let me clear all this hugabaloo out. Okay, so it's going to be 282 million people. And then I need to hit E, so I have to hit second, and then E to the X. And then I hit 0.0103 times 16. Hit enter, and I get 332,522,348.4 people. Griffin, can I have 0.4 people? No, not at all. So I am going to go back, but 0.4 is less than 0.5, so I'm just going to keep it at 332,522,348 people. Done. Example 4, K-Town. Kalodi Town has a population of 150,000, an annual growth rate. All right, so wait, initial population, P sub 0, 150,000. And a growth rate K of 0.0063. How nice is this? Glorious. Oh, you don't even have to calculate birth rate minus death rate. You don't even have to change it to a decimal. It's already done for you. Estimate the population in 20 years. Wow, this problem was handed to us on a silver platter. All right, so P equals 150 grand. Don't forget to write E to the 0.0063 times 20. I'm not going to go to my calculator here. I'm just going to tell you what I got. It's 170,142, and then it's 0.3 people. But you're not doing 0.3 people, so it's just the 170,142 peeps. That's it. I'll do 4 examples. I think that we're good. Okay, have a great day, everybody. Do your homework, ask questions if you have it. Bye.